When we deal with reactive processes, the main tool that we're going to use to analyze these processes will still be material balances. But in contrast to the systems in which the chemical species were just simply being mixed or separated, using molecular material balances isn't the most useful tool for these reactive systems. And that's because with molecular material balances, it gets a bit challenging or tricky to track all of the chemical species. And so in this video, what I want to go through is different ways that you could actually, different types of material balances that you could actually use when you're analyzing these reactive systems. Okay? And so there's different ways to perform a material balance for reactions. Okay? And so what I'm going to do is I'm actually going to draw a table here. All right? And so the three headings of the table will be molecular, atomic, and then extent to reaction. Okay? And I'll draw the little borders here in order to separate out the three sections. Okay? All right, and so we're going to go through each of these columns and discuss the different types of material balances that they cover. Okay? And so in the first column, I want to talk about the different features of molecular material balances. And so this is the type of material balance that we used in our previous example videos. All right? And so in a molecular material balance, what you do is you track the whereabouts of entire molecules. Okay? Entire molecules. All right? And so what I mean by that is you would track the whereabouts of moles of methane or moles of O2 gas, diatomic, or even N2 gas as well. Okay? Now, the molecular material balances can be either in terms of moles or in mass as well, as we saw with the benzene toluene distillation problem. So it can be in terms of mass or moles. Right? And so molecular material balances are convenient for systems in which you just have simple mixture or separation of chemicals. But when you start dealing with reactions, it is still possible to use a molecular material balance. But if your system starts to involve, multiple reactions, it becomes more cumbersome to use these molecular material balances. So cumbersome when multiple reactions are involved. Okay? And so really, molecular material balances aren't the ideal tool for analyzing reactive systems. All right? And so what I would suggest in lieu of using a molecular material balance is either using an atomic or extent to reaction material balance. Okay? And so let's move to the second column here. With an atomic material balance, rather than tracking the whereabouts of entire molecules, what you do is you track the whereabouts of individual atoms or elements. Whereabouts individual elements. And so, to be consistent with the methane, oxygen, and nitrogen example, if you're applying an atomic material balance on the same system, you would actually apply balances on either the carbon, the hydrogen, the oxygens, and the nitrogens. Okay? With an atomic material balance, these are done only in terms of moles. Right? And really, the advantage of using atomic material balances in reactive systems is they actually simplify the system in the event that you have multiple reactions occurring. So easy to use when multiple reactions occur. Okay? And that's because rather than focusing on the whereabouts of molecules, which will change during a reaction, if you use an atomic material balance, the atoms are always conserved, right? So it's easier to keep track of them. Right? Now, the other type of material balance that I recommend for reactive systems is the extent of reaction material balance. Okay? And so in this sort of material balance, you're also tracking the whereabouts of entire molecules. But what you're doing it in terms of the extent of reaction, which we introduced in the previous video. Okay? Now, when you're doing an extent of reaction balance, these are also only in terms of moles. Which is consistent with the statement previously, where the extent of reaction, right, is based on how many moles of a species reacted. Okay? Now, these extent of reaction balances are also useful for reactive systems, but they're especially useful if you have equilibrium reactions going on. Okay? And so we'll see an example of a case where we use an atomic material balance and an extent of reaction material balance in the following videos. The final thing I'll say here is that depending on the type of material balance they use, whether you use a molecular, atomic, or extent of reaction material balance, that's going to change slightly how you calculate the degrees of freedom. And to get more information about that, I recommend that you go back to chapter 4 in the book, which outlines, the different terms that you need in order to calculate the degrees of freedom for an atomic material balance or an extent of reaction material balance.